So for this antiderivative, with the denominator already being factored, we can see that this is going to be a partial fraction decomposition. So first thing is the setup. They're all linear factors. So will break into a over x plus b over x plus 2 plus c over x minus 1 dx. So our job now is to find a, b, and c, then we'll worry about finding the antiderivatives. Well, what I like to do is, okay, a needs to be multiplied by these two factors to find a common denominator. So a times x plus 2 times x minus 1. B will get multiplied by x and x minus 1. And c, x and x plus 2. And overall, we want this to be equal to the old numerator, 2x plus 3. Okay, so we have three variables. We should come up with three equations. And let me show you how that's going to happen. So first thing I'm going to do is I'm going to multiply these out. X squared plus x minus 2. B is going to get multiplied by x squared minus x. And c is going to get multiplied by x squared plus 2x. So then I'll distribute ax squared plus ax minus 2a plus bx squared minus bx plus cx squared plus 2cx. I like writing the constants out in front of the letters and the variables after. I think it makes it easier for the next step, which is to set up our system. What I like to do is set up our system by grouping powers of x. I've got x squared here, I've got x to the first, and I've got x to the 0, or the constants. Note, you'll see, and it's interesting, x isn't going to show up in any of my equations. I'm just grouping them. So first thing I'm going to do is the x squareds. I've got an a, b, and a c. So a plus b plus c needs to equal 0 because there's no x squared term over here. X to the first, I've got an a, 1a, minus b plus 2c, and that's why I like having the constant out front. Now this is for the x to the first, and there's 2 of them, so that should equal 2. Finally, I've got my constants. I get minus 2a, and that should equal 3. And this sets up my system. Now, we can solve this and solve backwards, but I want to show you a more general way that you can use using the calculator. What I'm going to do is I'm going to set this up as a matrix. And you don't need to have a whole lot of matrix experience to understand how this thing is set up. You're just doing coefficients of each line. Minus 1, 2, 2, negative 2, 0, 0, 3. So that's my system. Sometimes you'll see people put a dotted line. These were the answers, and then these were the coefficients of each equation. Now I'm going to show you with the calculator how we can do this. So we're going to go to matrix right there. We're doing a 3 by 4, and I forgot a step. I'm going to edit it. So I'm going to put in my line, so 1, 1, 1, 0, 1, negative 1, 2, 2, and negative 2, 0, 0, 3. Okay. Now that matrix is in there. I'm going to quit out, and you can see it if you go to second matrix. If I bring up A, there's my matrix. Now we want to solve this so our answers are right here. So what I do is I go back into matrix, and we're going to do some math on it. We're going to put it in reduced row echelon form, which is RREF, and we're going to put in specifically that matrix A, and what I get are my answers right here. If you would like them as fractions, right there. And there are our coefficients. This represents A, B, and C because that was their position in the columns. So solving this, we get, let's write them right here, A equals -3/2, B equals -1/6, and C equals 5/3. Now, let's put this all together. So we got the integral, we got -3/2 over x plus -1/6 over x plus 2 plus 5/3 over x minus 1 dx. Since we've already spent a lot of time on this one, I'm going to kind of quickly go through the last part, but these are just constants. In fact, we could rewrite this as -3/2 times the integral of 1 over x dx minus 1/6 the integral of 1 over x plus 2 dx plus 5/3 times the integral of 1 over x minus 1 dx. And now, hopefully you can see that it's basically 3 natural logs. -3/2 natural log of the absolute value of x, minus 1/6 natural log of the absolute value of x plus 2, plus 5/3 natural log of the absolute value of x minus 1, plus c. And if we wanted, we could make these powers and use some properties of logs to rewrite it, but this is fine for a final answer.